So in this video lesson, we will be talking about quadratic transformations. All right, it's going to be kind of a long video, so I'm going to go ahead and move right through it. So here is all of our function notation for our transformations in our quadratic functions. All right, and that just means how does the quadratic function change? Okay, does it move up or down? Does it move right or left? That sort of thing. This is how we describe our transformations. Okay, we have vertical transformations, horizontal transformations. Of course, we have reflections. We also have vertical and horizontal stretches, and we have vertical and horizontal compressions. I'm going to explain all of these individually in this video lesson. The first thing I want you to be aware of is that any changes that happen inside the parentheses results in a horizontal change, like it's going to be moving right or left, or it'll reflect across the y-axis, okay, right or left. Now, any changes outside the parentheses results in a vertical change, so it moves up or down, or it reflects over the x-axis, so it goes down or back up, okay? So again, inside the parentheses, horizontal change. Outside the parentheses, vertical change. All right, let's take a look. So here's our first example. We have f of x plus d. So remember, our original quadratic is f of x equals x squared, or y equals x squared. Let me go ahead and zoom in on that. So we have y equals x squared. Well, what if we add a 3 to that x squared? So x squared plus 3. Now remember, this is outside the parentheses. So when it's outside the parentheses, it's a vertical change. So let's look at what happened to the graph. You see we have the original in red. All right, and we just added 3 units, so it just shifted it up vertical. It's a vertical shift up 3 units. All right, let's take a look at this one. So again, let me zoom in here. So we have our function f of x equals x squared, or y equals x squared. And now we just say y equals x squared minus 5. So we're just subtracting 5 units outside of the, it's outside the parentheses. So again, if we take a look, see in our original in red, we just shift 5 units down, okay? All right, now let's move on. All right, so in this one, we have our f of x plus c. This is where we're adding a number inside the parentheses. So here I just want to point out, I had this done twice. So in our original quadratic function, f of x equals x squared, that's also the same as saying putting that x inside parentheses and squaring it. So y equals x squared. Well, this says y equals and then x plus 3 and then squared. So the change is inside the parentheses. Inside the parentheses means a horizontal change. So let's take a look at the change here. You see the original in green, and then this is x plus 3, and it shifts it horizontally. Now you would think plus 3 tells us to shift to the right 3 units. But inside the parentheses with the plus 3 here actually tells us to shift to 3 units to the left. Remember, when we talk about a solution here, and we want this to equal 0, we would put in a negative 3, because negative 3 plus 3 is 0. So that's why this actually is shifting horizontally, but you also need to know it has to shift to the left. So inside the parentheses, horizontal shift. If it's a plus 3, we're actually shifting to the left 3 units. All right, if we take a look at this one, f of x minus c. Okay, so again, we're changing inside the parentheses, but we're subtracting a number. Okay, so specifically in this one, we are subtracting a 4 inside the parentheses and then squaring. So again, minus 4, that's going to shift it 4 units to the right. Horizontal shift to the right, 4 units. Okay, you see the original here in green, and it shifts 4 units to the right. Okay, again, inside the parentheses, horizontal change. Call that a translation. It's a shift to the right. All right, moving right along. Okay, this one is a little bit different. This is where we have a change And again, it's outside the parentheses. So it's going to be a vertical or up or down. This is actually a reflection. Now, reflection can be up or down or right or left, but if it reflects over the x-axis, then it's basically kind of going down. It's reflecting up or down. So again, if we put a negative outside, let me zoom in. If we put a negative outside of the x here, not in the parentheses, but outside. I don't have parentheses drawn, but outside of the parentheses, it's going to shift it or reflect it across the x-axis. Okay, it's going to reflect it across the x-axis. So you have the original red, and then it flips over, and you have the new green here. All right. Now, here's another reflection. However, the change is inside the parentheses, okay? Or we put a negative inside the parentheses. So when you negate something or you make it negative, then it's going to be a reflection. If it's inside, again, inside means horizontal change, so it's going to shift right or left, which means it reflects across the y-axis. Yeah, there's actually no shift. It's a reflection, okay? But because it's inside, it's horizontal. Well, horizontal reflection means it reflects across this y-axis, so this positive 3 solution became a negative 3 solution. Now I gave you a different one here. This says y equals 2x plus 3 inside the parentheses. So remember, if it was the original, just y equals x, it would be here. The plus 3 shifted it to the left. So here's our original now, green, but I wanted to show you that when we made it a negative inside the parentheses times the 2x, it actually reflected it across the y-axis. All right, a couple more. So these are a little bit difficult here. Okay, this is our vertical stretch and our vertical compression. All right, what we've done is we've made a change outside of the parentheses, okay, to the x. So instead of saying y equals x squared, we're saying y equals 3x squared, or y equals a fraction of 1/3 x squared, okay? Okay, so this y equals 3x squared. So here in our diagram, here's the original green, okay? Here's the original in green. When I added this 3 and I made it y equals 3x squared, it actually makes it a little skinnier, okay? It's called a vertical stretch. If you think about it, if you have some hands and you're on the original green and you stretch it, so you pull up and you pull down, you're going to stretch it and it becomes skinnier. It becomes this blue one here, okay? So a number greater than 1, such as 3, it's going to become skinnier. If we make it a 10, it's going to become even skinnier, a 20, and so on. It becomes skinnier, okay? But if you make that a fraction, okay, a number that's greater than 0 but less than 1, so not a negative, but a fraction, such as 1/2, 1/3, 1/5, you see that it actually gets wider, okay? It's called a vertical compression because, again, let me show you. If we have these hands here, if you compress the original green, you push down from the top, push up from the bottom, you compress it, and then what's going to happen in the green one is that it's going to go out wider. Okay, it's going to go out wider. So a fraction makes it wider. It's called a vertical compression. All right, this is actually going to be our last one here. And again, this is another one where the change is made inside the parentheses. So we have a horizontal change. One is a compression, one is a stretch. All right, so again, if our original function notation is f of x equals x squared, or y equals x squared, and we go ahead and put it in parentheses to show it, it's in parentheses. If inside those parentheses we put a number greater than 1, such as 2 or 3 or 10 or 20 and so on, inside the parentheses, and then we square it, well, we're going to have a horizontal compression. Okay, horizontal compression. If it is a fraction inside the parentheses, it's a horizontal stretch. Okay, let me show you what those mean, okay? I'm going to use these hands here. Again, the original in this diagram from Desmos is the blue one, okay? Well, inside the parentheses, if I make that a 3, okay, which is a number greater than 1, it's actually going to be a horizontal compression. What we're doing is that we are compressing not vertically but horizontally, so we're pushing these two hands together, all right, and it's going to make the green one, all right, because we're pushing them together. It's called a horizontal compression. All right, if we go back to the original one and then we change it to a fraction, well, then it's a horizontal stretch, so we're pulling it right and left, and it ends up making the red one, okay? It's called a horizontal compression. All right, that was a lot in this video. Again, if you need to just go back, kind of pause it in different spots and take some notes, but also the assignment should help you walk through some of it or a lot of it as well.